Get this. Someone just sent over this wild research about some new glasses, right?
Yep. Yeah.
These lenses. They say they can actually slow down myopia.
Yeah.
Like, how cool is that?
Yep.
Scientists are always on the hunt for new ways to tackle myopia. It's such a common thing, you know?
It's true. It's becoming even more crucial now, actually.
Wow.
Some people are even predicting, get this, that by 2050, like half the world, seriously,
Yeah.
that's like everyone needing glasses. Okay, but seriously, that's exactly why this research on those new lenses, the DOT lenses, totally caught our eye, right?
Definitely.
Could this be like the big breakthrough, the game changer everyone's been waiting for?
Well, let's see. Let's break it down, okay? What's really cool about these DOK lenses is how they actually work.
Yeah, it's different. See, unlike your regular glasses, the ones that just change your focus,
Right.
DOT lenses, they use these tiny, and I mean tiny, light scattering centers. It's like, imagine like microscopic frosted patches, but like spread across the entire lens.
Whoa, so instead of seeing everything crystal clear, it's more like, what? Looking through a subtle, like, haze.
Exactly, like a controlled haze.
Okay.
And that's the key, you see, that slight scattering.
Yeah.
That's where the magic happens. It creates these little tiny differences in how the light hits your retina. The theory is, and it's a totally new way of thinking about it, that this difference actually reduces the contrast that tells your eye to, like, elongate, which is how myopia gets worse.
Wow, so it's like a completely different approach to what we're used to, right?
Yeah.
I mean, we always hear that reducing contrast helps with myopia.
Totally.
And this is like flipping the script.
Yeah, exactly. And what's fascinating is that, like, all the current myopia treatments, like those special contacts or even the atropine drops, they work in totally different ways,
Really?
They don't mess with the contrast signals like this.
Huh. So this is like uncharted territory then. Okay, so that brings us to that CYPRESS study you sent, the one diving deep into these DOT lenses, right?
Yes.
And this wasn't just a small, quick study, was it? This was like a big deal, right?
Oh, absolutely. We're talking large scale, 3 years long.
Whoa.
With hundreds of kids all across North America. And here's the important part. It was randomized and controlled. So, like, the researchers were sure that what they were seeing was because of the lenses, not just random chance.
Smart. They covered all the bases, so they knew the results would be legit. Speaking of which, what did they find?
So after a year, both types of DOT lenses they tested, way more promising than regular lenses at slowing down how fast myopia got worse.
Really?
Yeah.
So kids wearing these special lenses weren't becoming as nearsighted as quickly as the others? That's huge.
It is big. And they didn't just ask kids how well they could see.
Right.
They actually measured the changes in their eyes.
Smart.
Things like axial length and spherical equivalent refraction.
Okay, those sound pretty technical.
Yeah.
Can you break those down? What are they actually measuring and why does it matter?
Sure. Axial length, that's like the actual length of your eyeball from front to back, and it's a really good way to track myopia because, nearsightedness happens when your eyeball gets too long.
Right.
And then spherical equivalent refraction, that tells you how bad the myopia is, prescription-wise.
So it's like one is measuring your shoe size and the other is measuring how fast your foot is growing.
Yeah, that's a great way to put it.
One tells you where you're at and the other gives you a clue about where you might be headed.
Exactly. And what's really neat about the CYPRESS is that they didn't just look at those measurements on their own.
What do you mean?
They actually tried to factor in how much a kid's eyes would normally grow anyway, just from getting older.
Wow, so they didn't mistake a kid just growing up for their myopia, actually getting worse.
Yeah.
That's impressive.
Right. They used info from other studies to figure out what normal eye growth looks like for kids that age.
Clever. That makes their findings even more reliable.
Exactly. It adds another layer of accuracy, but wait, there's more.
No.
There are some other really cool things about this research, especially when you look at the results for different age groups.
Okay, now this is where it gets even more interesting. Let's hear it. What did they find when they looked at different ages?
Right.
Wait, hold on. We're talking about like little kids, right? The ones who are just getting used to wearing glasses in the first place.
Yeah, exactly.
Those are usually the toughest to treat, right? Like, good luck getting a 6-year-old to wear an eye patch. Forget about it.
Oh, tell me about it. And even some of the other options out there aren't exactly, kid-friendly.
Right, exactly. So that's what makes these results so fascinating. What exactly did they see with those younger kids?
So it seems like in that 6 to 7-year-old range, the DOT lenses were even more effective at slowing down myopia compared to the older kids.
Really?
And remember those axial length measurements we were talking about?
Yeah.
Those are especially telling in this age group. It's like the DOT lenses might actually be changing how their eyes are growing.
Whoa, so it's not just a quick fix. It could be like tackling the root of the problem.
That's what it looks like, and that's a really big deal if it's true.
It is. Imagine, early intervention is key with myopia, and these lenses could be huge for those early years.
Exactly, and think about it.
Yeah.
If you could start kids off with these lenses early on, maybe, just maybe, they wouldn't have to deal with, like, really bad myopia later in life.
It's like a whole new world of possibilities.
It is exciting, right? But, we've got to be real. Even with these amazing findings, the CYPRESS study isn't over yet.
Right. It's ongoing.
Yeah, we're only looking at the first year of data.
So it's like we've just watched the first season of a really good show, and now we're left with the cliffhanger.
Exactly. And like any good TV show, there are always a few surprises along the way.
Oh,
The researchers did point out a few things to keep in mind.
okay. Let's hear it. What are some of the limitations?
Well, for one thing, remember how we talked about those DOT lasers having a kind of unique look with the micro diffusers?
Yeah.
It was tough for the researchers to, like, completely hide who was wearing them.
So some kids might have figured out they were wearing the special lenses, and maybe that changed how they acted or what they told the researchers.
Possibly it's something to consider. And then there's also the whole thing with the two different DOT lens designs they tested.
Oh, right. They had the one where the micro diffusers were more spread out, and then the other one where they were packed in tighter.
Exactly. And while they both had good results, the less dense lens, the one with the more spread out diffusers, seemed to work even better.
But they're not sure why. Talk about a cliffhanger.
I know, right? It's definitely something they're still looking into. And one more thing.
Yeah.
All the kids in this study were 10 or younger, so...
So what works for them might not work for teenagers or adults.
Exactly. More research is needed to see if DOT lenses are effective for older age groups.
So much more to learn. But even with those limitations, this whole study feels like a huge leap forward. It's like opening up a whole new path for treating myopia,
Absolutely. It's generating so much excitement. Researchers are already asking all sorts of cool questions based on these findings, like, what if we could actually personalize those contrast signals?
What do you mean?
Like, what if we could tailor the treatment based on someone's genes or their specific risk factors for myopia?
Personalized myopia treatment. That's wild. It's like something out of a sci-fi movie. Instead of just getting a stronger prescription every year, we could be like fine-tuning those light signals, actually guiding how the eye grows.
I know, right? It's a pretty amazing thought, and the fact that we're even talking about this, it just shows you how much potential this research has.
Totally. It's like we've found this whole new way to talk to the eye.
Exactly.
We're not just trying to fix blurry vision anymore. We could be shaping how the eye develops, all because of these tiny little things on a lens.
It's pretty incredible when you think about it.
It really is. And it makes you wonder, what else is out there? What other discoveries are just waiting to be made?
Right. We're really just starting to scratch the surface of understanding myopia.
It's funny. We started this whole thing talking about how half the world might have myopia by 2050. But after learning all this, I feel, kind of hopeful. Like maybe it won't be as bad as we thought.
I get it. This research definitely gives you a reason to be optimistic. Like, we might be on the verge of a totally new era for myopia treatment.
And to think, it all started with you sending us that research paper. Who knew a simple pair of glasses could be so groundbreaking?
That's the beauty of science, right? There's always something new to discover, always more questions to ask, and sometimes the biggest breakthroughs come from the most unexpected places.
Couldn't agree more. Well, on that note, we're going to wrap up this deep dive into the world of DOT lenses and the future of myopia. Huge thanks to you, our expert, for breaking it all down for us.
Happy to do it. Thanks for having me.
And to you, listening, thanks for sending us this research and sparking this whole conversation. We hope you found it as fascinating as we did. And don't forget to check out the show notes for links to the study and other resources if you want to dive in even further. Until next time, stay curious.